Have you ever really thought about what's flowing through your veins right this second? I mean, we call it blood, but it's so much more than just red liquid. It's this incredible, bustling highway of life, carrying literally everything your body needs to survive. So today, let's take a deep dive into that inner river and really explore the amazing world of your blood.
So here's what we've got on tap. First, we're going to break down what's actually in our blood. Then, we'll take a trip to the factory where it's all made. After that, we'll meet the body's emergency first responders, see what happens when that system goes wrong, and finally, we'll get a clearer understanding of blood cancers.
Okay, so let's jump right in. If our blood is this vital river, what are the building blocks? What's it actually made of?
You know, it's so easy to just picture blood as one uniform thing, right? But when you look closer, it's a whole ecosystem in there. You've got your red blood cells, your white blood cells, all floating around in this liquid called plasma. It's this constant, super dynamic flow of all these specialized parts, each with its own job.
And get this, it might sound a little strange, but technically blood is considered a type of connective tissue, which, when you think about it, makes perfect sense. It's the ultimate connector, right? It links every single part of your body by carrying these different cells, the red ones, the white ones, and platelets, all suspended in that plasma.
And we are talking about a lot of it. The average adult, you've got about 5 to 6 liters of this stuff circulating through your body nonstop. I mean, that's a huge volume, constantly on the move, every second of every day.
So what is all that blood doing? Well, it's basically a master multitasker with 3 critical jobs. First, there's transportation. It's like a delivery service for oxygen and nutrients. Then, regulation. It keeps your body's temperature and pH balance just right. And finally, protection. This is your frontline defense, fighting off infections and healing wounds. Pretty amazing, right? Okay, so that brings up a really big question. Where do all these incredible, specialized cells even come from? Well, to figure that out, we need to take a trip to the factory floor, right where it all begins.
The official name for this process is hematopoiesis. Yeah, I know it sounds super complex, but the idea behind it is actually pretty simple. Think of it as your body's personal blood cell manufacturing line. And the most incredible part, it all starts from just one single type of stem cell.
Probably the best way to wrap your head around this is to think of it like a family tree. Right at the very top, you have the great-great-grandparent of them all, the multi-potential stem cell. And from that one single amazing cell, every single type of blood cell you have is born. It's the common ancestor for everything.
So, from that one common ancestor, the family tree splits into 2 main branches. On one side, you have the myeloid line. This branch is responsible for making your red blood cells, the platelets you need for clotting, and most of your general-purpose white blood cells. Then, on the other side, you have the lymphoid line. This branch creates the special forces of your immune system. We're talking the highly specialized T cells and B cells.
All right, now that we know where all these cells come from, let's see what they actually do in an emergency. It's time to meet your body's very own first responders, the emergency repair crew.
Think about this for a second. Have you ever gotten a little paper cut and just watched it? It just stops bleeding, all by itself. It seems like a little bit of everyday magic, but what you're actually seeing is a perfectly coordinated, high-speed emergency response.
So, this whole process is called hemostasis, and it happens in 3 key stages. Step 1, the blood vessel itself actually squeezes down to slow the bleeding. It's called vascular constriction. Step 2, the platelets, those tiny cell fragments we talked about from the myeloid line, they rush to the scene and form a temporary plug. And finally, step 3 is blood coagulation. A whole cascade of proteins kicks in to create this web of something called fibrin, which acts like a biological superglue, forming a really tough, stable clot to seal the deal.
And you can really see this incredible piece of biological engineering right here. It all starts with that broken vessel. Then, boom, the platelets swarm in to create that initial plug. And finally, you see those fibrin strands weaving this incredible net that traps everything and seals that wound for good. But what happens when this perfectly elegant system breaks down? That brings us to our next section, when our own blood can sometimes turn against us.
One of the most common problems you hear about is anemia. Now, it's really important to get this straight. This isn't a problem with bleeding or clotting, it's a problem with transportation.
Anemia is what happens when your blood just can't carry enough oxygen, and that's either because you don't have enough red blood cells or the cells you do have don't have enough of that crucial oxygen-carrying protein, hemoglobin.
And when you understand that, the results of this oxygen deficit are suddenly crystal clear. The symptoms, fatigue, weakness, feeling out of breath, they all make perfect sense when you realize your body is literally being starved of oxygen. And under a microscope, the difference is just so obvious. Fewer red cells simply means less capacity to deliver that vital fuel.
Now let's flip over to the protection side of things. That's where you find conditions like hemophilia. On the left here, you see our efficient little repair crew doing its job perfectly. But on the right, with hemophilia, the body is missing some of the key clotting factors, and that means even a tiny bump can cause major bleeding because that final fibrin net, that biological superglue, it just can't be formed properly. And that brings us to the most serious breakdown of all, a hostile takeover of the blood cell factory itself. And that's really the best way to understand what blood cancers are.
Leukemia is at its core a cancer of the bone marrow. The whole problem starts when that factory starts pumping out abnormal white blood cells. And these cells don't just fail to do their jobs. They multiply completely out of control, and they end up crowding out all the healthy, functional cells your body desperately needs. Remember our family tree chart? Well, we can actually use it again here to understand where different types of leukemia come from. The cancer is classified based on which of those two main branches, the myeloid or the lymphoid line, is the one that's producing the rogue cells.
So the four main types of leukemia are basically classified in two ways. First, by the cell line where the problem starts, so is it lymphoid or myeloid? And second, by how fast it grows. Acute means it's fast-growing, while chronic means it's much slower. This gives us the four main types: ALL, which is more common in kids, and then AML, CLL, and CML, which are all more commonly found in adults.
When you really step back and look at the whole picture, our blood is this incredibly complex, finely tuned system of creation, defense, and repair. It's just amazing. But seeing how it can fail, it really makes you think, doesn't it? What does the fragility of this inner river really teach us about our own?